Something extraordinary just happened. A quantum computer is now orbiting Earth. For decades, quantum computers were fragile, room-sized machines never meant for the chaos of space. But a team of scientists and engineers has defied the odds, shrinking this technology and making it space-ready. Now, that tiny quantum computer circles our planet, marking a new era in both space exploration and computing. This leap opens doors to super-secure communications, advanced climate models, and smarter satellites. It's not just an experiment, it's a stepping stone to a quantum-powered future. We're witnessing the dawn of a new frontier, much like the first computers in office buildings decades ago. Let's dive into how this was achieved, what makes quantum computers unique, and why this mission matters. This is a story for anyone who's ever looked up at the stars and wondered what's next. The journey of the first quantum computer in space has just begun, and we're all part of it. On July 10, 2025 at Kennedy Space Center, a Falcon 9 rocket launched a small satellite carrying a fully operational quantum computer. The device, Quasar-1, is a marvel. Its quantum processor fits on a chip smaller than a fingernail. Years of innovation by Quantum Leap and international partners made this possible, overcoming immense engineering challenges. The launch was flawless. The rocket soared, the satellite detached in orbit, and Mission Control received the signal. Quasar-1 was alive and ready. Unlike previous experiments, this is a complete quantum computer, not just a test of quantum effects. Its mission-run quantum algorithms process data and send results back to Earth. This marks the start of a new race, not just to space, but to a quantum future among the stars. Humanity has sent one of its most advanced creations on its boldest mission yet. The world watched as a new chapter in technology and exploration began. Quasar-1 is now a pioneer, proving quantum computing can thrive beyond Earth. The quantum space age has officially begun. What makes a quantum computer so different from your laptop or phone? Traditional computers use bits, ones and zeros, to process information, like tiny on-off switches. This system is powerful, but some problems are so complex that even supercomputers would take millions of years to solve them. Quantum computers use qubits, which can be both 0 and 1 at the same time thanks to quantum mechanics. This property, called superposition, lets quantum computers explore many solutions simultaneously. Imagine a maze. A classical computer tries every path one by one, but a quantum computer explores all paths at once. This makes quantum computers uniquely powerful for certain tasks, like drug discovery, new materials, or breaking complex codes. They don't just do things faster, they do things differently. Quantum computing is a new way of thinking about problems, opening doors to solutions we never thought possible. The leap from bits to qubits is like moving from a bicycle to a rocket ship. That's why sending a quantum computer to space is such a big deal. It's not just about speed, it's about unlocking a new universe of possibilities. The future of computing has arrived and it's orbiting above us. Qubits are the heart of quantum computers, and their magic lies in two key properties: superposition and entanglement. Superposition lets a qubit be both 0 and 1 at once, like a spinning coin that's both heads and tails until it lands. When measured, the qubit collapses to a definite state. But until then, it holds all possibilities. Entanglement is even stranger. Two qubits can become linked so that changing one instantly affects the other, no matter the distance. Einstein called it spooky action at a distance. These properties let quantum computers process vast amounts of information in parallel and link solutions together in ways classical computers can't. With just a few hundred entangled qubits, a quantum computer could outpace all the atoms in the universe in terms of combinations. This power isn't about making faster laptops. It's about solving problems that are impossible today. From stimulating molecules for new medicines to revolutionizing AI, qubits are the key to the next level of innovation. The magic of qubits is why scientists are so excited and why this mission matters. Quantum computers are built for the unsolvable, and now their magic is at work in space. The possibilities are limitless. Sending a quantum computer to space is a monumental challenge. The launch is violent. Extreme vibrations and g-forces threaten to destroy delicate quantum components. On Earth, Quantum computers need ultra-stable, cold environments. In space, they face radiation, temperature swings, and isolation. Radiation can instantly destroy a qubit's fragile state, a process called decoherence, the arch-nemesis of quantum computing. Maintaining the ultra-cold temperatures needed for stability is tough when a satellite swings between blazing sunlight and freezing darkness. There's no one to fix it in orbit. The computer must be self-sufficient, running diagnostics and correcting errors on its own. Overcoming these obstacles, launch violence, radiation, temperature extremes, and autonomy, required groundbreaking engineering. That's what makes Quasar 1's success so remarkable. It's not just a technical achievement, it's a triumph over the harshest environment we know. Every moment it operates in space is a victory for science and human ingenuity. The mission proves we can push quantum technology far beyond the lab. The impossible is now reality, and the adventure is just beginning. Why go through all this trouble? Because space offers unique opportunities for quantum technology. Satellites today collect data and send it back to Earth for analysis, a slow, bandwidth-heavy process. A quantum computer on board can analyze data instantly, enabling real-time decisions, like detecting wildfires or monitoring crops. This is edge computing at its most advanced, processing information right where it's collected. Quantum satellites could revolutionize climate science, resource management, and disaster response. The ultimate goal, a global quantum communication network. Entanglement could enable perfectly secure, unhackable channels, relaying quantum signals across continents. In the vacuum of space, these signals travel farther and more reliably than on Earth. Quantum satellites are the first step toward a new era of secure global communication. Making a quantum computer space-ready took radical innovation. Engineers designed shock-absorbing systems to protect the quantum chip from launch vibrations. Multi-layered radiation shields and advanced error correction software guard against cosmic rays. Instead of bulky cooling systems, Quasar 1 uses passive radiators and heat pipes, keeping the processor cold by radiating heat into deep space. Solar panels power the system, making it efficient and compact. Onboard AI acts as mission controller, monitoring health, running diagnostics, and optimizing quantum tasks. This blend of physical protection, smart software, and autonomy makes Quasar 1 a true survivor. It's not just a computer, it's a self-sustaining explorer. Every system was reimagined for the harshest environment known. That's what sets this mission apart. We're still in the early days of quantum computing. Quasar 1 isn't a supercomputer yet. It has a modest number of qubits and faces challenges like decoherence. Its main mission is to prove the technology works in space and gather crucial data for the future. Think of it like the Wright brothers' first flight, a small step that opened the skies. Every calculation, every error, and every lesson from Quasar 1 will help build better, more powerful quantum satellites. This mission is a foundation for the future, a proof of concept that pushes the boundaries of what's possible. The road to a quantum internet and fleets of quantum satellites is long, but this is a bold first step. Progress comes one breakthrough at a time. Quasar 1 has already inspired scientists, engineers, and dreamers worldwide. The future of quantum technology in space is bright, and it all started with this tiny, trailblazing satellite. The launch of the first quantum computer in space marks the dawn of the quantum space age. Soon, more advanced quantum satellites will follow, each building on Quasar 1's legacy. Imagine a network of quantum satellites forming a planet-sized sensor, monitoring Earth and the cosmos with unmatched precision. This could transform navigation, climate science, and even the search for new worlds. The ultimate dream, a global quantum internet, with unhackable communication and distributed quantum computing across Earth and space. This achievement bridges quantum mechanics and space exploration, pushing the boundaries of human knowledge. The little satellite above us is more than hardware, it's a beacon of progress. It lights the way to a future where quantum technology helps us understand our planet, secure our world, and reach for the stars. The journey has just begun, and the possibilities are limitless.